Uh, a warm welcome to everyone. Today we are truly honored to have Jayant with us. He is currently in his fourth year at NIT Warangal, pursuing a major in mathematics and minor in computer science. Jayant has an exceptional profile. He has completed a research internship in deep learning and also worked as a data analyst intern at Fixity Learning Pad. Over the years, he has built a strong expertise in data science, machine learning, and artificial intelligence. And adding to his achievements, he has successfully completed 10 plus projects in the field of AI, ML, and data science, showcasing both deep and consistency in his work. He also runs a YouTube channel named Jant AI Lab, where he shares valuable content on AI and shares valuable content uh, on machine learning to help students and enthusiasts grow in his domain. We are truly glad to have him here today. I am sure his insights and experience will be incredibly inspiring and helpful for all of us. Okay, over to you, Jayant.
Thank you, Shivans, for your kind introduction. Yeah, today we are going to discuss about the topics, the prerequisite Langchain topics, which will help us for our end-to-end RAG project or as well as our agentic project, right? So let me start the project. Means for the project, I have taken only those concepts what are required for the projects only. I am not covering all the topics of Langchain, right? Let me start my screen. Can you give permission, Shivans,
Yeah.
to share screen?
Krishna.
Yeah, now I could able to. And also, yeah. Hope you could able to see my screen, right? Anyone?
Yes, yes.
Yeah. Thank you. Thank you. Okay. Yeah. Now we are going to see the framework Langchain, right? Now you might be wondering why Langchain only, right? See, Langchain, what is Langchain? It's all written here clearly. It's an building AI application with LLMs. Let's say you want to build any application with GPT model or Cloudy model from Anthropic or Llama model from Facebook or any LLM, large language model. Yesterday, Ankur sir very nicely elaborated about all these concepts, right? LLMs, LLMs, and some topics of Langchain were also there, which are helpful in our RAG workflow. And we are going to into the depth so that you will get complete understanding when we are doing the end-to-end project tomorrow and in future classes, right? Now, Langchain, right? Now, let's understand little bit more about it, right? We'll directly learn from the documentation itself. See, the main topic here today, two things you are going to learn today. What are those? The prerequisite concepts of Langchain for our project. And the most important thing is that how to learn, any tech stack, right? Let's say I want to learn Python. Let's say I want to learn machine learning. Then what is the approach? What is the right way? What is the right way? Right? What is the right way? The right way is first we go through the documentation of the authors who are presented, who are developed the model. We will directly go to the documentation and understand what exactly it is. Langchain documentation, you can see. I'm going to Langchain document. You can also search. And the front page itself, it's saying that Langchain is a platform for agent engineering. Okay, I could have able to understand a little bit. And these are the other products they are also given, Langsmith. We are not going to cover those, but yeah, we will understand only Langchain today. And in the Langchain also very little portion which are required for our projects. That's it. Right? Now the first page itself you can see here. Langchain is the easiest way to start building agents and applications powered by LLMs. Right? It is the easiest way. Why it is the easiest way? Because it will help us to do our LLM problem statement very efficiently. How? Let's go back to machine learning. On the first day, we started with Python and machine learning, right? Hope you're able to recollect that. See, when we want to build any machine learning project, in our project, what we did, we first load the data, and we cleaned the data, we pre-processed the data also. Means a considerable amount of time we spent on data preparation. But when you come to the deep learning, you don't spend this much amount of time on data preparation, data loading, data scraping, all these things we don't spend much time. See, first generally data engineers prepare the data. They will give a CSV format file, and we did the data cleaning so that any duplicates or any null values, so that we can clean it in a format that is useful for the model, machine learning model. Means, yeah, we have to spend a considerable amount, like say 40% of your entire life cycle of a machine learning project, you have to spend on data part. Then comes the deep learning. Here you'll spend only little bit of it, because the deep learning itself, the models themselves learn the features. You don't have to explicitly, let me take pen and explain here. You can see here. See, you can see the screen, right? Now in machine learning, what we do, we need features like let's say I want to predict the dog. What I have to do, I need shape of the dog, right? I need color of the dog, correct? I need some other features, length of the tail. Like this, we will have some table, like this table we will be having, right? But when it comes to deep learning, what you do, you directly give an image. You can see here, directly we are giving image to the DL model. Then what is happening? It will automatically creates the features. And we it is abstract. We cannot able to understand also, because the purpose was higher now. From deep machine learning, we came to deep learning, where the data amount of time you are spending on the data was decreased. Now you are coming to Gen AI, generative AI. Now think of it, how much time we have to spend on it, right? So the Langchain will make all the arrangements for us so that we can cook readily. All the ingredients it will prepare for us, and we directly take them and put on the dish and complete it. Your item is ready, right? So Langchain is a framework which will help us to build efficiently, very productive way to build any LLM application. So we are going to see that what are the components that are required for our project only, right? Now let's get into I have given the introduction, right? So we will go to the concepts that are required for our project. And let me stop this. And you can see I'm going ahead. Here you can see, you can ask doubt at any point. You can on your mic and you can talk, right? Because I may not see the messages right now. At the end of the class, soon I will see, right? Now, document loaders. Why we need document loaders, Jayant? If you ask this question, because there are many LLMs we have LLMs from different companies, right? And they specify that I want data in one format. Google says I want data in JSON format, and some other LLM says I want in this format. But what Langchain does is it created one data structure, and it will use this data structure for all the LLMs. For all the LLMs, it will use this document data structure, right? It will. This is the one and only data structure we have in the Langchain. It will be used in complete Langchain ecosystem. And what is that and how it will look like? I will show you that one. Right? Here we are taking only one example. What is this? PyPDF directory loader, which I am using in my project, so that you will be comfortable when I am explaining the code. Let's go through this definition. See, document loaders load data from various sources and convert them into Langchain document objects. This is very important. So that I see, this is the format that I needed for the LLM. You're able to understand or not? This is the format. In machine learning also, we did so much work, right? We did so much work to get in the right format. But now that work is automated by the Langchain with just a simple import statement we have to do. Right here you can see here PyPDF directly loader example I have taken. What it will do, let's say what it will do. Let me take the pen. You can see here. Let's say you have a directory, means you have a folder. Let's say you have a folder. In these folders, there will be PDF1, there will be PDF2, there will be PDF3, right? Now, all these things at a time will be loaded. All these things loaded in the document data structure format. You are able to understand or not, right? So this PyPDF document loader will automatically load any number of documents present in that folder. That is the use of this in the document format. That is very important, right? Now you see here Langchain community document loaders. I'm just giving the code example so that you will be comfortable when you see the code in the end-to-end project. Here, how it will be, how you just have to you just have to import it from documents. Where documents is present? In the Langchain community, right? In the Langchain community, documents is present. You can see here Langchain community document loaders is there in that PyPDF document loader. How I know this change? Please tell me. I will tell you. You just go to the Langchain documentation. Now go to the integrations part here. Here you can go and see. Yes, document loaders is there. Yes. Now here you search document loader. You can clearly understand. Document loaders provide a standard interface for reading data from different sources, like from Slack, from Excel, from Drive, from anywhere into the see. This is very important, into the Langchain document format. Let me go to this document. This is what I am talking about. This is a data structure that Langchain is using. What it contains? It contains two parameters. You see here, Langchain core underscore core. Here documents. You will be having this class, document class, right? In this document, you have page content, whatever see, you have a PDF. When you have to extract that first, right? You have to extract that only we are doing. We are extracting the data using PyPDF document loader, right? And we will keep that here at this place. And any metadata you can give anything, right? Where the source, right? From where you got that data. And this is the what document we needed, right? This is standard in Langchain. Now you can see here, this ensures what? This ensures the data can be handled consistently regardless of the source, right? Now this is the load function. This will help us to load the data from the document from your PyPDF loader, right? You can see here another also CSV loader also is there, right? There are many loaders. According to your data, you have to understand what to use, right? It is already present here. Let's say you have data in your web. What you will do? You will use this one, web. You will use this web. Unstructured data is there. You will use this package, right? Like this. PDF is there. Yes, I have PDFs. Now, PDF you can use PyPDF. I also have another question, Jayant. That is why all these are present in this integrations part. It is why it is not there in Langchain, but we are studying in Langchain. Anyone having this doubt? Right? Because PyPDF is a package. It is independent of Langchain actually. Now I will search, you see. PyPDF. I will search here. It is independent. It is independent. Before Langchain exists, it already exists and everyone is using it. But what Langchain does, it integrated to itself. Are you able to understand? Like this, you see, PyPDF is already present library and it is using this library. So we are integrating it into the ecosystem of Langchain. So it is present in the integration section. Right? Now, what we are going to study, this one I have written PyPDF directory. What is present in this? You see, what we need is these things. I already said code is from here only, everything from here. I have taken from this itself. We have, see, Langchain community. They are telling you have to import like this. Langchain community document loaders import PyPDF directory loader. Because of that, I have written in this one here. You see, same thing I have written. And I'm using everything same. And I got this information from the documentation. And there are two ways of learning. I want to tell this. This is very important. How to learn anything. That is the most important thing. Right? See, there are two ways to learn. But the first way is I have documentation, Jayant. And what I will do from this documentation, let's say something I didn't understand. What the traditional way of doing? I will go and search some blogs. Okay, in blogs I didn't find James. What I will do? I will see some videos. And this is used to be the learning. Okay, let's say videos are also not present. Then what is it? Some person, other person, senior, let's say senior. Senior we will ask. Who are comfortable in what you want to learn. This is one way. This is a traditional way of learning, right? Now, what is the other way? You have documentation. This should be the first important note is we have to start with the documentation only. The other way is then you, let's say you didn't understand anything.
Yeah.
Some specific part, right? Some specific part you didn't understand. Now, what you'll do? You'll use some cloudy AI model, cloudy or chat GPT, right? Anything you can use so that you have to understand it, right? And what is the benefit of this approach? It will save time. It will save a lot of time because here the answers are direct. Now, if you go to the blog and you have to search which part my answer is there. In videos, also complete video you have to see like this, right? And this approach is better only you have to understand some language, not the concept. The second approach, not for understanding the complete concept, because you cannot understand complete concept and it cannot stick into your mind with the chat GPT or any AI tool. So to understand the text, to understand only the formal language or pre-processing, something like that, we will use this approach. Otherwise, we will search some videos and we will understand from some blog like that concepts. But some are very easy to understand with the chat GPT, and at that time we have to use the AI tools so that our productivity will be increased, right? So now let me go to the next concept. I will show you how to if I don't understand any document, means any documentation, any language, right? Any part of the documentation, I will also do that in between, right? So that we will learn. Now here you can see, I already showed load function will be used, and using this we will load. And here some analogy also is there. I hope you understood this, right? Now we'll go to this part. Text splitters. Okay. Now I have loaded the data in the document format, but it contains huge chunk. One whole book is present in the document. Can I use this directly? The Langchain ecosystem says no. The framework says no. You have to break it into the chunks. Why it is telling like that? Can anyone, right? Can anyone tell me why we have to break our content into chunks? Our content into chunks, right? Right? Because let's say you have some file, uh, generative AI principles, some file is there, some document is there, right? Some document you have, which is named as generative AI principles. It contains all about agentic RAG, how it works, what are embeddings, what are vector databases. Let's say this is your document. This is your document, right? Now if I ask any question for this document, what will happen? I'm asking any question, what will happen? The model has to search on the complete document. Are you agree with me or not? It has to it has to it has to search on the complete document, and it is waste of time, it is not efficient, and it has to take the complete information, and number of tokens will be increased, automatically cost will be increased. So what we do is we convert this document into chunks. We divide it into paragraphs and we store them. Where we store them, yesterday Ankur sir very nicely elaborately discussed, we store them in the vector database. Ankur sir also discussed why we need vector database, how it is different from traditional vector databases, right? In these chunks we store in the vector database, vector db. I hope you are able to understand. Now let's say this is about embedding. This block is embedding. Now I am asking question to this vector database, tell me about embeddings please. Then what it will do, it will only give me this information output. Are you able to understand this part? And all this is redundant, not required for me. But in this case, if you directly load this, then it will give complete information as output. But it is waste of money, time, and everything. Right? I hope you understood why we need to make into chunks. And what will help me to make into chunks? This recursive text splitter will help me naturally to convert a document into chunks, right? Convert the document into chunks. Let me erase this one quickly. Anyone having any doubt here? Anyone? Right? Now let me go to the definition. These text splitters divide large documents into smaller chunks that can fit within the LLM context window. They intelligently split. You see here, text while preserving semantic meaning and context. The most important thing is that how the LLM understand what is before this chunk, what is after this chunk, right? Let's say if we see the document, I can understand, yes, okay, before this part LLMs were discussed. Before embedding, after embedding, vector database was discussed. I can understand. But when we are doing recursive, means when the computer itself is doing, how it will understand? It should intelligently do this, right? How it is doing? Let's understand that one, right? You see here, recursive text character splitter. For what it will do? First, it has a whole document. First, it will make it into paragraphs. Then it will chunk to sentences. Then it will chunk to, you can see here, it is a flow actually, words. And this is a template, means how to practically implement it, right? From the Langchain text splitters, recursive character text splitters will be there. And in this, you see, you might be having these questions. How much size that chunk should be there? How much size that we have to mention? We have to give actually. Here you see, 1,000 I have written. Chunk size means number of words, number of tokens that should be there in the chunk. And why this one? Chunk overlap is 200. Why we need overlap? Can anyone tell? Why we need between two chunks? Why we need some overlap? Can anyone? right? We need overlap because to understand the context, what is happened before, what is there next, so that LM will understand what is before and what is next, right? So that it will give you the right answers, right? Now, how it is working, how recursive character text filter is working, how it is working. Let's see. Let me go to the Langchain actually, so that we'll understand nicely what they have written. Because from this documentation only we have to learn. If you're not able to understand, we will search something, right? Now we are at now we have to go to the text splitters. It is present here itself. And you see, text splitters break down into chunks and the model context. What is written? Model context window limit. See, here also written other reason, some other reason. I think you may not understand this one right now, but yeah, recursive text splitter. If you click on this, you will have in-depth understanding of this. This text splitter is recommended for generic text. Generic text. It is parameterized by a list of characters. It tries to split on them in order until the chunks are small. See, you might be thinking why James is going to the documentation and explaining. Because I can also make another one note or another note separately from this, right? But the point is, learning happens like this only. Learning happens when we understand how to learn. How to learn. This is a way. We know we will understand some concept. We will know the topic and go to the documentation. Let's say we didn't understand. I already told two approaches, two ways. And we'll go in the two ways and we'll understand any concept. Right? Now you see here, tries to split on them. What is this? Okay, I will explain. You can see here. Let me take the pen. Now, let's say some paragraph is here. You can see my screen, right? Some paragraph. This is one paragraph of the document. This is another paragraph of the document. This is another paragraph of the document. Now, here two lines are there. Two lines, two spaces means two lines of spaces, right? That we indicate with this one backslash n, like this, right? One line is one backslash and two lines means two backslash n's. Means you're telling to the computer that if you find any two lines of spaces, then you consider it as a paragraph. Like this, it able to understand it is a paragraph. Are you able to understand? Right? Now, okay, I understood it is a paragraph. But let's say this paragraph is of 5,000 words. Could be. We don't know. Could be. Let's assume the worst situation, right? Let's say 5,000 words. Then we mentioned that our chunk size is 1,000. 1,000 is our chunk size. But it is 5,000. It is crossing the limit. Then what to do, Jayant? You don't have. We have very nice logical text splitter. What it will do is now 5,000 words were there. What it will do? It will again chunk by sentences. Are you able to understand? How it will understand sentences? If there is any backslash n, one backslash n, then it will understand it is a sentence. And this 5,000 words will be converted to something 4,000, let's say. Then again it will check. No, chunk limit is 500. User told 1,000 words, but again it is 4,000. Again it will recursively. Are you able to understand why it is the name recursive? It will do on continuously. It will do until the chunk size and chunk overlap is matched. Are you able to understand? Yesterday these were presented to you on yes, in the rack structure. These will be there, loaders will be there, text splitter will be there, and embedding model will be there, vector database will be there. Right now I am going to the depth so that when I use this you will be comfortable. That is the only goal of the lecture actually. You can see now I have 4,000, then it will convert into 1,000. Then yes, satisfied. What user told is satisfied. Now again, now our splitting is done like this. and chunk overlap is 250. What does it mean? Means 250 words will be common in this chunk, and let's say this is chunk number 1, and let's say this is chunk number 2, and common in between these two. I hope you are able to understand my writing, because yeah, it's not that much neat actually. So please adjust. You can see in between 1 and 2, the overlap will be 250. Means 250 words will be in intersection. If you take intersection of both of them, then 250 will be in intersection. So that model will understand the context, what is happening before, what is happening the next. Right? Now, let me clear this. And now you understood how recursive text splitter works. Right? Anyone having any doubt in this? Anyone? You can feel free actually. No issue. If you ask anything, it doesn't matter. Right? We are trying to understand and we are trying to learn. So yeah, this is a code. They are telling you can import like this. So I did like that. Yeah, you can see chunk overlap 20 they kept and 100 chunk size, right? Like this, you can understand. There are many other parameters also. You try to explore this one. I'm giving this walkthrough of the documentation because you'll be comfortable when you want to walk alone, right? That is the point. Now, okay, you understood. Like cutting a cake, first that natural layers, then smaller sections, then small sections. Then we will understand vector databases. Yesterday, vector databases were elaborately discussed by Ankur sir. So I will give just the definition who are not in it. You can see vector database store documents as natural vectors, numerical vectors. This is very important because it will not because AI cannot understand your English natural language. Machine learning models or any generative model, they don't understand your English, but still they are able to give in the English as output. How? There will be one encoder, there will be one decoder. Encoder will convert your natural language to the embeddings, mathematical representations, a vector, right? And decoder again, when the model generates another numerical vector, again decoder converts your mathematical representations to the English language. That is why you're able to understand, what ChatGPT is giving. ChatGPT is able to understand like this. It has encoder and decoder, both, right? Means both components are work separately, but this is what their use is, how model is understanding. That's what I want to tell here. Now, one of the example that we are going to use in our project is this Facebook AI similarity search. They tell that it is extremely fast similarity search library that handles billions of vectors efficiently. Can anyone tell me how we can get the similarity between any two vectors? How it is connected to mathematics? Did we study anything related to this? Can we understand anything? We want similarity. We want similarity between two vectors. But in mathematics, we never study similarity. We study it, but abstractly. How? It's like this. Similarity means the dot product only. Dot product of two vectors will give you similarity. Because what dot product contains, let me write that. Let me take the pen. Let's say you have two vectors. Let's say you have two vectors A and B, A dot B. What is A dot B? Modulus of A, modulus of B into cos theta, right? Cos theta is nothing but cosine similarity, right? This is cos theta will measure the angle between the two vectors, A dot B divided by modulus of A into modulus of B. Cos theta is measuring the angle between your two vectors. If your two vectors are near, then they are similar, right? Are you able to understand intuitively? If the two vectors are like this, theta, let's say this is vector 1, this is vector 2, right? Vector 1 and vector 2. Let's say I will take another vector also. Here, vector 3. Now, what is the angle between? This is, let's say this is theta 2. This is theta 1. Now, theta 1 is less than theta 2, right? In high dimensional space, these vectors will be in the space, and we will try to find the angle between those vectors. And if the angle is less, then they are similar. They are trying to convey the same meaning. In this way, the computer will understand whether the vectors are whether two words, two sentences are similar or not. So that is the reason we are converting any natural language like this, any text, we are converting into a mathematical representation of vectors like the 0.2, comma 1.0.1. Yesterday it was discussed, right? Like 1.1, like this. It is a vector. And between two vectors, another vector also is there. And we will find the dot product here. And we will get and we will understand how similar they are, like this. I hope you are able to understand, right? Now let's go through how practically we can implement this FASIS, right? This Facebook AI similarity search. How can we implement practically in our project? Langchain itself gives. They only tell you have to use this code. They only telling that from the Langchain community you will get vector stores. In that we have FASIS. Is it really there? Let me check once. Is it really there? You can see here vector stores is there. All these are in the part of integrations only, right? I hope I already given why they are present in integration, right? Integration because there are some other modules. Langchain was trying to use them into its ecosystem. Let's see what are the things are there. See, let's understand this part, this architecture as well. This is also very important. It's also very important. See what it is telling. You have a, let's say you ask what is RAG. Let's say this is your question. This is a question query. This is a query. Now what I have to do? I have to use an embedding model and I have to create a vector 0.2 something something. I have a vector, right? And in beforehand I have a document where all the answers are present. Let's say some PDF. Let's say some PDF. GenAI principles. GenAI. This is a PDF. Right? This is a PDF. Now, what this PDF? I used the embedding model. I used some model, embedding model. Let's say OpenAI embeddings are there. OpenAI. Yesterday it was also discussed, right? OpenAI embeddings, Google embeddings, right? I can. What is embedding? What it will do? It will create. It will give you a mathematical representation, something like this, something like this. For all the chunks, it will give. For every chunk, we will be having a vector, right? And then we will store them in the vector store. In this, we will store. And now your vector is here, right? And you are doing a similarity search with all these documents. With all these documents, you are doing similarity search. Means what you are doing? You are doing the dot product or finding the cosine similarity between your vector and the query vector and all the vectors that is present in the database. And you will get the top k results. What is the top k results? Those are the most similar to your query vector, right? Are you able to understand this architecture diagram, this framework? Anyone? Someone? Yeah, nice. Not Haimesh also. Yes, yes, right. You can, because we can have interactive session like this, so that we can understand where you are not able to understand, so that I can understand. That is the only reason I'm asking questions, right? You can see, right? Now this is clear for you. I hope how what we are exactly trying to do and how generative AI is working. Without vector databases, we cannot imagine generative AI only, right? Vector database concept is very important. And before that, if someone asks what is unique about AI, what you will tell? Interview question, let's say. What is unique about AI? What you will tell? Unique about AI is data. Without data, AI is nothing. Are you able to understand that? Right? Now, we will try to understand what all the methods are there in this. you can add documents to the vector database as we like I showed there, right? You can add the documents and you can do similarity search on the so that we will understand we need some vectors which are similar to our vector, right? This abstraction, let's see abstraction which is done behind the scenes, right? Lets you switch between different implementation without altering your application logic. See, Langchain is that it is super powerful that you don't have to change any code, irrespective of the application, irrespective of the logic. You have to do the same thing. That is the power of Langchain, right? Are you able to feel that? Right? You can write S in the chat. Right now, you can see how we have to add documents. Now, see before that, see from the we have to get the code from the documentation only. We have to remember this indirectly? Yes. How? By doing more projects, by doing more practice, by referring documentation again and again. We have to keep them in our mind so that now see now many companies are coming for the placement. I can say recent experience HP has come and it only asking Langchain. Langchain, it is only asking Langchain, nothing else. And package is 26 LPA. Can you imagine? That's what we are learning today, right? Because this will help you. That's what I told in the session before the session starting. Also, it will help you in future. That's why documentation I'm walking you through so that you can come again and see what all things are present and explore, experiment. Machine learning and AI is all about experimentation, right? It's all about experimentation. Now, let's say you want to delete any document. How you will delete? You will use a document ID and you will delete. Because document IDs are that is why important. IDs are very important when you're giving document, when you're storing the document inside your vector database. We have to generate some random ID so that you can refer the document again. It's like index, right? In dictionary, you can see that key value pair. Key will be there, value will be there. Value is our document now. What is the key? Your ID. So that you can refer it again, you can delete it, you can do many things, right? You can do many things. Return a number of results, right? How many results you want. You can also specify that here. Right? Everything was I have taken from here. They're nicely explaining cosine similarity, Euclidean distance. There are three different ways of getting the similarity, right? I think you can go through this. Now the point is, I have to show you where this facet is present. Here they are telling that top integration because these are all paid. So we are not going to use paid things so that we are in the learning phase, right? When you are doing an end-to-end real world project, we will go with the paid because they are consistent in response, they are reliable, and there are many advantages of the paid things. Now you can see here, as is here, they are telling from the Langchain community, from the document store, you take this memory, and from the vector stores, you can import this facets, and you have to use like this. They are already explained us how to use and everything, right? I hope you are able to understand how I have prepared this PPT itself. Because every definition, everything is from the documentation itself. So that it will be authentic, right? Be authentic. Now, I hope you understood as is how there is more depth we can go in that also. But that is scope, that's not in the scope of the video right now, right? How it is actually working, how CAS is working. But we are now trying to use it right now. We will go in depth, right? In someday, right? In future classes, if possible, we try to go. But I am trying to cover what the essential for tomorrow project, right? Now you can go through this. What else? No, yeah, chart models. Now we have to use some LLM, right? Conversational AI interfaces. We have to use some LLM, right? Let me read the definition. Chart models are specialized LLMs designed for conversational interactions. They support multi-turn conversations, role-based messages, and main context across exchanges. I think this might feel a little technical for you, but the point is that we have LLMs, right? Let me take my pen. Is the response? Okay. I could not able to see the time. It's already 12:15. I think more 15 minutes only present. Okay. We'll cover whatever possible today. More 15 minutes, or we'll extend more 10 minutes if possible. Everyone is fine for more 10 minutes extension today? Everyone fine today? More 10 minutes? You can write in the chat if possible. Okay. Shiva Harshit is saying fine. Kunal saying yes. Yamesh is also saying yes. Okay. Anyone? Okay. 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 We can extend, I think. Okay, more 10 up to 12:40. We will see to 12:40. Whatever we can. Venu also saying very nice to hear these responses. Right, very nice. Now we'll try to up to 12:40. We'll try to do how much we can, and we will continue in the tomorrow's class, and we'll do the end-to-end project tomorrow also. Right, but I will try to complete today itself. Right, it's 12:15 right now. More 25 minutes. I think. Yeah. Now chart. We have LLMs. We have LLMs. But why chart models required? Please tell. Please, right? Because let's say you have an LLM. See, we have many LLMs, Llama is there. Llama is there. You can adjust with my syntax, my writing, please. So Llama is there, Cloudy is there, and Gemini is there, and GPT is there. Many models are there, but they know. See, I practically experienced these before Langchain when I was doing my internship at Fixit Learning Pad. First, I developed my complete code base with GPT. My complete code base with GPT, because at that time ChatGPT is only there, Cloudy is not there. Cloudy is not there. Only ChatGPT is present. And with GPT, I completely means they have their own input format, right? They have their own output format, and my complete code base is in this format. But when Cloudy came, we understood that it is more efficient than GPT. It is more better than in all the metrics. It is better than GPT. Then we have to completely change everything according to the Cloudy's input format, output format. You know how much hectic work is this, right? But what Langchain does, it's very wonderful, right? We only have one framework here, only one way of defining things. If you want to change something, you just have to change the model name. That's it, and API, model name and API. Those two things only you have to change. Only change is name and API, model name, API. That's it. Nothing else we have to change when you are using this Langchain framework, right? It's such a powerful framework, right? Now chart model is because when we have the LLM, they won't sometimes what I think you might not be experienced with ChatGPT, but when we are using open source models, you might be experienced that you are asking something and it is giving something. It was not able to understand the prompt, right? It is not able to understand the prompt. So what the chart models means, how they build the chart models is that they will try to fine tune again with the chat interface. Like I will give one question, you respond accordingly. Give me one question, you respond accordingly. And they are training on this part so that they will be a chat models. And these chat models are extensively used in Langchain. And you will see those. We will see that more, right? I am trying to take this one example, right? Here Bedrock is there, AWS. From AWS, Amazon Web Services, as you all know, Chart Bedrock is one of the chart model from them, right? From Chart Bedrock, I can also use Cloudy. They are telling Llama, other models also, right? Because AWS is providing us, and this is a frame. This is a practical implementation, guys. You can see here. You see from the Langchain, I have to import this. Okay, we will see. I hope you understood the backside of it. Why I have written this code, because I have written this because Langchain says this simple thing, right? This is what they are telling. This is what I am trying to follow, and this is what I have to give the input. See, I am trying to use from chat better. There are different models, as I told you before. Cloudy is there, Llama is there, other models also there, and I can use one model from from the Anthropic, and some model arguments, temperature. I think you'll know better if you understand transformer architecture. Then you will understand what is temperature and what maximum tokens, how many How many tokens you can understand just as words. How many words should be there in the output? 512 we are mentioning, so that we can reduce our cost, right? So we can constrain, we can restrain that cost also, right? And convention, see how to invoke, how to get the output. See, this is invoke function is same for every model you use, for every LLM to get the output. Remember this, guys. Remember this one. This is such an important method. It will be same across all the LLMs, all the embedding models, anywhere, right? This is same. That is what Langchain has built here. Langchain was, you can see the Langchain main power is this only. It is generalized for every model, for every company. Any company can come. Langchain will integrate into its ecosystem, and anyone can use it efficiently and productively, right? And I'm asking what is Langchain, and response.content you will get out. I personally experienced many actually how this works, because every input for a tool, see how tool should be defined. I think yesterday Angur sir also discussed how tools will work. I think maybe, or we will discuss in future when we are trying to build agentic RAG. This will be discussed, right? Again, one session will be there like this only, so that you will be comfortable with the on the all the concepts before going to the project, right? I hope you understood this part, right? Now we will try to clean this part quickly. Anyone having any doubts here, please? I cannot see the chart frequently also. If you can talk, that will be nice. Chart Bedrock is one model we are trying to use because it is free. That's the only reason. Otherwise, we will go with the OpenAI or Gemini, like that. We are trying to use the free resources so that you can also use them in your project. You can also keep them in your resume if you want, like that. So let me go through this as well. I will show you where it is present. I will not go into the depth. Chart models is there. And there are different models. See, chart anthropic, chart OpenAI, everything is present here. And chart completions API also you can use, and many. See, these are all the integrations. These are all the integrations how Langchain did for us who want to build agentic applications. They did. And here, I think here itself it is present. Chart Bedrock should be there here. Is it there? Yes, it is there. You can see chart Bedrock. Here, chart Bedrock, that this doc will help you to get started with AWS Bedrock. If you want to explore it, you have to just read this. Few lines, but very, very powerful. Very powerful. And the application that we are making, right, those are powerful. That's the only thing. See, our purpose is huge. We want to solve a bigger problem. So we don't work on small things, writing complete code from scratch to extract information from a web. Like in previous 2 to 3 years back, the project itself is to extract, right? To extract information using beautiful soup, some other libraries to extract information from a website. But we are automating it right now because we have something higher. We want real time information. We want some day to day life use cases to solve. That's why we automate some things, and this Langchain is helping us in that way, right? Now now we will go through. It is complete almost. Now this is very, very important. Very, very important. I will take the pen. See, it's very, very important. 1240. You can see, right? It's I will let me take the pen, sorry. It's chain. See, Langchain itself, the name itself has a chain. Now imagine how important this concept of chains. The name itself contains this chain component. Right? What is this chain exactly is doing? Right? You can see here, chains are sequences of operations. Sequence of operations where output of one component becomes input to the next. Let me give the example. Let's say you have one component of your project is, right, prompt. Of course, yesterday chat prompt template was covered, right? How, what is chat prompt, it was covered, Angur sir. And you have a prompt, user will give something, and that will be inserted in the prompt. User will be there, prompt, it will be inserted in the prompt, and prompt should go to the model, right? And model should go to the some parser. Why we need parser? Model will give some output which is in the not right format that we required. So we use Langchain output parsers so that we get the output in the right format and we will get the output. And imagine what we have to do is that if you don't have chain concept, what we have to do? First, we have to define the prompt like this. Let's say some prompt is there. Now, let's say some model is there. Model dot, again, we have to give this prompt manually. Manually, I have to invoke like this, invoke prompt. Then when I get the output, then I have to something like this. Let's say this is parser. Into this parser, I have to send the model output. Let's say this is output. And I have to send this into the parser. And I will get the output, exact output that is required for me. This is all these I have to do manually. But this chain concept is such an amazing that you have to write simple code like this. You define your prompt individually, model like this. You define your prompt like this, model like this. And this is the syntax of the chain. Chain is equals to my prompt pipe operator. This is called pipe operator. You can see it like a stick. And you will write here model. And then here you will write, what you will write? You will write parser. That's it, guys. You will get the output. What it is doing automatically is that now we will invoke chain. We will invoke chain. Here I am writing chain dot invoke. Whatever input, let's say I have to give some text to the prompt. I have to give some text to the prompt like this. That's it, guys. And you will get the output. Are you able to understand? Write yes in the chat. Are you able to understand or not? Right? This is the power of chain. Now, what is sequential chain, Jayant? What is sequential chain? Someone given response, I think. See, Hamish is good to understand all the things. I hope everyone also. Right? You can also be interactive, right? Also. Right? Now you can see here. This is what chain does. Now, sequential chain is something not special, but yeah, we given some name. This is sequence only, right? See, I have a user prompt. Prompt is there, then sequence model, then parse. This is only sequence. But here some example also there, which is which is little higher than this. Let's say, like I have to clean the screen. I have to clean the screen. Oh, to clean the screens. Now, here we trying to take some text, let's say. No, you're trying to give some query like, please generate a company name, let's say. Like this, like say you have some company and you have some description about company, what company does, something like this. And you want a name for the company, right? You want a name for the company. Now user is present here. User have some query asking the model what they are asking. No, first user will use something and it will go into the prompt. It will be inserted to the prompt and this prompt will go to the model and model will give out. Parser could be there. I'm not writing the parser here. I'm just writing the output. You can understand that one, right? Now, what I got in the output? Company name I got. Company name I got. But I want some slogan also. Based on this company name, I want some slogan. It can be done in one step also, but we are trying to understand sequential chain. So now this output, this is output 2, output 1. No, this output 1. Again, we'll go to some other prompt. This is, let's say this is prompt 1. This is model 1. This is prompt. Hope you are able to understand my writing. Prompt 2. And here from the prompt 2, it will go to again model 2. And from the model 2, it will come output as output 2. And everything will be done by this chain, guys. Complete thing is automated. You don't have to give manually. Before I showed how we have to give manually. Now nothing should be given manually here. This is one chain, this is another chain. You are sequentially joining these two chains independently. You can see here, you can see this code, guys. Here you see. See, I'm creating first name chain. Sorry, I need rub eraser. I will rub this one. Now I will again, you can see, you can see here, you see, first I am creating name chain so that I can get the name, and I am creating the slogan chain so that I can get the slogan using this name. Now what I am, see here, sequential chain, what it is doing, it is taking the name chain and the slogan chain, and input variable is your product, right? Some product you want to use, right? Using that product you want to create the name and you give the slogan, and this will be done automatically. You just have to call overall, like this, overall dot invoke, like this you do, and output 2 you will get directly output 2. Are you able to understand? Are you able to understand or not? Right? How you are able to get a sequential chain, how it is powerful enough so that it is automating many things, right? Right? You can write S in the chat if you are able to understand, right? Then let me clear the screen and we'll move forward. We'll move forward. This is very nice example, right? So that we can understand what sequential chains exactly are and how we can use it in our project. This is practical implementation, guys. This is a practical implementation, right? It's a practical implementation. Now we'll move forward. We'll move forward to something. This is very abstract and very. This is like the building block. Let's say you have many rooms, right? I was sitting. I'm sitting in one of the room of the building. You are also sitting in one room, right? In your home. But there is some base foundation is there for your home, right? Runnables are like that for the Langchain. Runnables are the foundational concept for the chain. Now we are using, before invoke, we are using this one. Let me take the pen. With this concept, we will conclude. And this is the last slide as well, right? And we will complete. Now you see, runnables. What runnables are? Runnables are the foundation of the Langchain expression language. You don't bother about what is language here. You just have to understand it is a foundation. It is a unit of work, guys. It's a unit of work. Unit of work. What is that work? Work could be like this. It will take input. It will take input. It will give output. What is there? What is there in the chain? It is there. Something is there here. What is that? That is what the power here. See, what is anything which will take input and it will process. It will work here. It will work something. It will work here and it will give output. That we call as a runnable. Right? See, before we use chain, right? What chain is? Chain is there, and it will take input. What input? It will take input variable from the user, and it is doing so many things inside, and we are getting output. Right? This is work he's doing here. Work. So much work is going here. Do you think is it an example of runnable? Anyone in the chat? I'm waiting. Anyone in the chat? Is it example of? Is it the example of chain? Is it the example of runnable? Sorry. Anyone? Ramesh is responding. Shiva Harshit, are you able to understand? Venu, everyone, right? This is the example of chain. This is the example of your runnable, right? This is the example of your runnable. Okay. Now, we can use on all the runnables, we can use these things. These are common. This is common. What is common? What is common? Right? Here you can see here. This stream is one method is common for all the, what is batch? Multiple inputs. Multiple inputs I will give and I will get multiple outputs. That is batch. What is stream? Stream means, oh, I will give you a very nice real world example for stream. Right? Okay, I cannot go now outside because I am writing now. Say you given some query to ChatGPT. GPT you are giving. How it is generating? It is generating word by word, right? Did you observe that? It is not giving. It is not like I will prepare and I will give you after some time. No, this generating in front of you only. Step by step, it is coming. That is streaming. Means it will not keep anything with it. as soon as it generates something, it will give. That is streaming. Are you able to understand? Right? There is so much more depth for this concept. You have to explore that, right? For our concept, I was trying to, so that you will be familiarized with these words, with this technology, right? See, I am using this runnable passes through. I am using in the project. What it will do? Passes input through passes input through unchanged while allowing other operations useful in rack systems. Means I will give something input and it will not be affected, and I will get the same output. Input and I will get the same output. It will not be affected. But we need this. That passage we need. So we will see that passage in the next class. Means in the when I'm practically implementing, you will understand it completely. Right now, you got the basic understanding. It will do some work. And chain is one of the example, right? Invoke is a method which is common for all the runnables. And you can see here what I'm doing. I'm importing Langchain core runnables like this one. As I showed before, these are also present in the Langchain documentation. Lack of time, I'm not going through it. So Langchain pass through, you have to import and see. As I told before, syntax of the chain like this. A pipe operator. Can you see here a pipe operator? This one, circle. Whatever you get output of this runnable, you will pass through this lambda function, and you are converting into an uppercase. Some example, this one, right? Some example, right? And we see what is this. Hello, you are passing hello to this chain. What it is doing, it will give output as capital hello, right? It will give output as capital letters. In all the letters are capital, right? Capital hello, right? That in that way, it is not changing anything. Some the same thing is there, your information is same, but some format is changed, right? Are you able to understand that? Now in the rag chain, rag preserve question and preserve question plus add context. Let's say retriever is there. Okay, I have to explain these concepts in the next class, or when we are doing the next unit. After this project, I will explain what is retriever, and many things are there, tools, agent, everything, right? I hope it is clear. And yeah, we will understand it practically in our project. I will make sure we will be completely understood. And if you're having any questions, please ask now, right? Please ask on your voice. You can mute and you can ask. You can unmute, right? And okay, we are moving forward. This is the last thing. No, that's it, right? Whatever I have taken from the Langchain documentation itself. Are you able to understand? We have to first understand the documentation. Okay, some difficulty is there, and we have to go through the resources. That is the correct way of learning, right? Yeah, with this, we'll conclude. I will conclude this session. Yeah, thank you. You are in mute, I think. Sheshwansh.
So, thank you, Jen, for giving such a wonderful, nice class on the Langchain and giving details and basic details and fundamentals of Langchain. And also thanks to all participants for hearing patiently and gaining wonderful knowledge. Thanks.
Yeah. Thank you. Thank you, everyone.